All right, so this next page outlines the steps for a hypothesis test for one population mean using the t-test in general, and then we're going to walk through a couple examples with more specifics. But again, we're going to use the same steps we did in the last section, using the acronym PHANTOMS to keep all those steps in order and so that we don't forget any. So in the first one, we're going to be looking at a parameter. In this case, since we're dealing with quantitative data, that parameter is going to be the population mean. So this is, mu is going to be the mean measurement of all the objects, which then our corresponding random variable for that from the sample will be x bar, which is going to be the mean measurement of n randomly selected objects. The H for phantoms is hypotheses, and so for this one, again, our parameter now is going to be mu instead of p. The null hypothesis is still going to be mu equals some specified value, and then depending on the wording and what we're trying to prove, we're going to either choose mu is less than, greater than, or not equal to that specified value. The A from phantoms is assumptions, so this test also has its assumptions, which are different than the last one because it's a different test and different type of data. So for quantitative data, we want a random sample of size n. We either want a population that's normally distributed or a sample size that's at least 30 with no outliers in it. Now, if you're given data, you can use the methods from 6.4 to see if normally distributed population is a reasonable assumption to make by looking at the histogram, the modified box plot, and the normal probability plot. So we would want a roughly bell-shaped histogram, but that's really hard to tell usually with small data sets. So usually the other two we look at more closely, so there should be no outliers on the modified box plot, and the normal probability plot should look roughly linear. And then the last one, which is almost always a given, is that the population standard deviation sigma is unknown. So in this case, we use S in these problems instead. So if those conditions check out, the N for phantoms is to name the test we're going to use, and if those conditions are met, then we're going to be using the t-test on our calculator. The T from phantom stands for test statistic, so thinking about the sample statistic that we start with, quantitative data, that's going to be x bar. And our standardized test statistic score, we're going to be looking at for a t-test now, a t-score. So again, we're going to take x bar minus mu sub 0, so to figure out how big that gap is, and then we're going to divide it by s over root n for the standard deviation. So again, t-scores are also going to count standard deviations away from the claim. And then the O in phantom, still obtaining the p-value. So we're going to go into the stat test menu t-test, and we're going to find that t-test. And in this case, we have the option next to input to either highlight data, if we have a list of data sitting like in L1 or someplace, wherever we would have put it, or we have been given a set of summary stats, and so then we will highlight stats and put that summary stat x bar s n information in here. And again, we'll either have a two-tailed test, a left-tailed test, or a right-tailed test, and we're going to make a picture to kind of summarize all that information. For quantitative data, though, now our random variable is x bar, and we're running a t-test, so the standardized scores underneath each of those values of x bar will be a t-score. All right, then the M from phantoms is to make a decision about H0. That decision-making process is still the same. If the p-value is less than or equal to alpha, we'll reject, otherwise we will not. And then lastly, S is to state a conclusion in context. So again, if we reject the null hypothesis, there is significant evidence to conclude HA. And if we fail to reject the null hypothesis, then there's not significant evidence to conclude HA. Again, the only difference in those two conclusions is the little word not, but it's just like back in 7.1 with the jury's decision. It's either guilty or not guilty. Okay, so those conclusions only off by that one little word, but that one little word makes a huge difference in the context of the problem. And again, we never, ever, ever say except H0.